Alright, our objective today is to relate a fraction of a set to the repeated addition interpretation of fraction multiplication. In other words, today we're going to try and move away from the models that we've been using in previous lessons. We used arrays, we used tape diagrams and counters, but we say that we're moving from the model to the concrete to the abstract. So we're going to look at some different examples and see how we can work around them. So if we're given with 2/3 of 6, because I know multiplication means something of something, using a model, one way to go about this is to draw a tape diagram, split it in 3 parts, and I know in this situation that my whole is 6, alright, and I would like to find 2/3. In order to do that, I need to identify one unit, or the unit fraction as we say, and in order to find one unit of 6, which is 1/3 of 6, what I will need to do is to divide 6 by 3, which gives us 2. So I know each unit is equal to 2. In my original equation, I'm trying to identify 2/3 of 6. So if 1/3 of 6 is 2, it means that 2/3 of 6 will be 2 times 2, because each unit is 2 and 4. As you can see, these two together, they give me 4 if I add them up. So this is one way of using a tape diagram to identify 2/3 of 6. Another way to go about this is that if I see my tape diagram, I know that 3 units are equal to 6. 1 unit will be 6 divided by 3. So each of these units are 6/3. I need 2 of these units. So 2 units will be 2 of 6 divided by 3, because each unit is 6/3, which means 6/3 plus 6/3, which is 2 times 6/3, which is 12 divided by 3, and that gives us 4, the same answer that we got before when we used the tape diagram. Another way to look at this, if I have 2/3 of 6, I know that based on the commutative property of multiplication, or the turnaround rule, I know that 2/3 of 6 is equal to 6/2. What does this mean? I have 6 of this quantity that is 2/3. So if I were to write this as an addition, I will repeat 2/3 6 times like this. Essentially, we have 2/3 repeated 6 times. I can rewrite my equation like this as well. So as you see, I have 2/3 6 times repeated, which can also be written like this. And I know 2 times 6 is 12/3. I get to the same answer as before, which is 4. Let's look at a different example. If I have 3/5 of 10, and I wanted to solve this without using a model, I know that is equal to 10/3/5, which means I have 3/5 repeated 10 times. So I can rewrite my equation like this, and I know 10 times 3 equals 30, divided by 5 equals 6. If I look at this equation carefully, I can also simplify it by looking at the numerator and denominator. I can see at 10 and 5 have a common factor, and this will be 5. I can divide both by 5, so 10 divided by 5 is 2. 5 divided by 5 is 1. So my numerator now is 2 times 3, which gives me 6, and 5 divided by 5 was 1. 6 divided by 1, the answer again is 6. Let's look at the last example for today. If I have 7/6 of 24, it means this is equal to 24 of this 7/6. It means 7/6 is repeated 24 times. Therefore, I can rewrite my equation like this. And I can think now if I can further simplify this and see any part of the numerator can be simplified with the denominator. I know that 24 and 6 have a common factor, which is 6. So I will go ahead and divide them both by 6. 24 divided by 6 is 4. 6 divided by 6 is 1. Therefore, my equation turns into 4 times 7, 28 divided by 1, which is 28. And that's it.